This is the Calculus Pre-Lecture Series. I'm Brandon Ashley, and this video will be on improper integrals. So there are two types of improper integrals. The type 1 improper integrals are integrals of functions evaluated to negative infinity or positive infinity. And so these might look like some function which goes out to infinity, f of x, and we want to calculate the area under the curve starting at some value a and going all the way out to positive infinity for the x value. Well, we would write the integral from a to infinity of f of x dx is equal to the limit as some parameter b goes to infinity of the integral from a to b of f of x dx. And so instead of taking the integral from a to infinity, we don't know what that means, we instead let infinity be b and then take the limit as b goes to infinity. For type 2 integrals, we'll do something similar, but these are going to be integrals of functions with discontinuities. And so we might have some function which looks like this, f of x, and say it may not even be defined at some value a. And I want to take the integral from this x value a out to some other x value b. So I might get some area that looks like this. And this is going to look like the integral from a to b of f of x dx. But again, the function wasn't even defined at a, so instead we're going to write this is the limit as some parameter c this time goes to a from the right, so we'll put a little plus there, of the integral from c to b of f of x dx. So those are our type 1 and type 2 improper integrals. So let's look at a couple examples of these improper integrals. These two are both type 1 improper integrals. And if we want to integrate the first, the integral from 1 to infinity of 1 over x squared dx, we just replace infinity with the limit. So I take the limit as b goes to infinity of the integral from 1 to b of 1 over x squared dx. And then this becomes the limit as b goes to infinity of the integral of 1 over x squared is just minus 1 over x evaluated from 1 to b. And then we evaluate it at the limits. So I get the limit as b goes to infinity of negative 1 over b minus negative 1 over 1. So this just becomes the limit as b goes to infinity of negative 1 over b minus negative 1 is plus 1. And we know that negative 1 over b as b goes to infinity is just going to go to 0. And so we're just left with 1. So we'll say that this integral converges to 1. And we can do a similar thing for the second integral here. I'll take the limit as b approaches infinity of the integral from 1 to b of 1 over x dx. Again, if I take the limit as b goes to infinity, the integral of this piece is just going to be natural log of x evaluated from 1 to b. and we write the limit as b goes to infinity of the natural log of b minus the natural log of 1. But the natural log of 1 is just 0, and we're left with the limit as b approaches infinity of natural log of b. Well, that goes to infinity as well. So we're just left with positive infinity as our answer, and we say that this integral diverges. So we had one integral converge and the other integral diverged.